solve most systems, but it has its place on the teaching side of things. So we are going to go back and we are going to graph some more. Okay? Let us do so. You all can go ahead and put these two into an appropriate form to graph easily. Because, of course, we, being in the 10th grade, will not be doing something so elementary as a table of values, will we? Go. And what, pray tell, is the solution? He waits patiently while his students graph two lines. 3, -4. Agreed? Excellent. That is what I like to hear. Now listen to me and listen to me carefully. Without screaming the number right now, and some of you are still going to do it even though I'm going through this big thing right now about how I don't want you to do it, all of you pick a number between -10 and +10, write that number there, and then do these 3 things. Go. I do the comedy. I love it how that's where kids get stuck. Pick a number between -10 and +10. Any number? Could I use a half? Yeah, you could. That's the whole point of a number. Trust me. I will wait a few moments. That is as long as I need to wait. The first person to say their number in an Azerbaijani accent, exactly, no one's going to say a number. That's why I'm doing it. No, see, as I was saying, it needed to be in an Azerbaijani accent. I know, that's why I did it. No, it's Turkish, but northeast. Anyways, somebody say one of their numbers. Okay. Shut up. I've already got it. No, idiot. Yeah? Solve for y. And no matter what you did here, once you solve for y, what did you find? You got the exact same line, right? Now, The equation gave me the same line. Right? Now, what does that tell you? Multiplying both sides of a linear equation results in what? It gives me a new equation, right? A new equation in looks, but what is it in reality? In reality, it's the same equation, right? And you have seen this in math already, haven't you? 3/7. If I multiply all parts of that by any number, give me a number, 4, I get 12/48. So what am I doing? 12/28. Are they the same? Excellent. Now, you're intelligent young people. If you multiply them both by the same, it stays the same. What happens if you divide them both by the same? It still stays the same, but looks different. Everybody with me? That is key. Same values, different looks. Everybody cool? Keep that in the the prefrontal cortex, because we're going to be accessing that in a moment. Well, one specific part of your brain. I don't want you to put that in your limbic system. I don't want you to use that when you need to fight or flight, when a giant alligator is chasing you down. I do not want you thinking, oh my God, if I multiply a fraction by this, okay, I want you to run, okay? Don't put any math in your limbic system, ever. You don't even know what I'm talking about.
Are you not supposed to scream numbers at animals when they're chasing you?
All right. Now, we are going to compartmentalize what we just learned. We're going to put it off on the side in its own little subfolder. Yeah, of course you're going to forget it. We are going to come to this, and the question says that I wish for you to add these equations. That seems odd, doesn't it? But we are going to do so anyway. When I add in algebra, what must be the case? I can only collect like terms. So this 4x can only add to this 5x, yes? So how many x's will I have at the excellent? What happens here? 3 plus -3 is 0y, which I would never write down, would I? No. Equals what? 27. Everybody agree? Now, what would you do, algebraically speaking, with that? You would divide by 9 in order to isolate x, yes? Let us do so. What does x equal? 3. Now I have asked you to graph that on the grid above. I do not care if you turn back a page. You can just look. Where is x equals 3? 1, 2, 3. And for x always to be 3, it would be somewhere on this line, yes? What do you notice graphically? It goes right through the intersection, doesn't it? So we notice that. What happens? The resulting equation graphs a line through the solution. Yes? But it's only half the solution, isn't it? Right? Now, that was what happened graphically. What happened algebraically at this yellow line? Right. Why? What happened that allowed us to know what x was? Pardon me? Before we isolated x, we added both the equations, and what did that achieve algebraically? What did it do? It eliminated a y value. So algebraically, it'll catch up. It will catch up. Magic. Now, it will relish. It will mustard. Now, ladies and gentlemen, why is that a very important thing to have had happen? We couldn't do this because we have two unknowns. But when we did this, we have resolved the situation to having only one unknown. Okay? Now, let's subtract them. And this is a little weird. What's 4 minus 5? Negative x. What's 3 minus 3? Plus 6y. And what's 0 minus 27? Negative 27. If I wanted to graph that, of course, 6y would equal x minus 27, and y would equal 1/6 x minus 4.5. Yes? 27 over 6, right? Yeah. Now, if I were to go back up to this graph, and you don't have to, minus 1, 2, 3, 4.5, yeah? And up 1 to 3.5, and out 1, 2, 3, 4, 5, 6, what do you see happens now? It also goes through the solution. So what does that tell us about adding or subtracting? It results in new equations, again, because we're changing them. New equations that can do two things. What's the first thing that they did? What happened in the first one? What did we do here? And what did it result in? Eliminating a variable, right? Eliminate a variable. Or 2, it gave us, we've already got new equations. It gave us another equation to work with. Maybe that other equation is easier to work with. Everybody with me? So, sum up. Can I multiply the equations to change the looks of them? Will it maintain the integrity of the solution? Can I divide the equation to change their looks and maintain the integrity of the solution? Can I add them? Can I subtract them? Yes. All of these tools are available to us in order to change the looks to solve the system. Everybody cool? So, knowing what you know, I want you to write one more equation somewhere under here that will have the same solution as this system. Go. Everybody's is going to be different. That's the point. Just write another equation. That's all you got to do. When you're done, make a noise like a wombat. I know, I'm doing it on purpose. I will give 5 gummy bears to anybody who can tell me the animal collective name for a group of wombats. 5, 4, 3. No, the animal collective, like a flock of pigeons. 5, 4, 3, 2, 1, 0. It is a wisdom of wombats. Wombats are one of my favorite animals because they poop cubes. Wombat poop is a cube. All right, back to math. Now, just for fun, so you can leave here with something that, you'll actually care about and use in the real world. Here are 5 more interesting animal collectives. A murder of crows. A conspiracy of ravens. A parliament of owls. A crash of rhinoceroses. No, rhinoceroses. And a sounder of swine. Pigs. 5 fun animal collectives that you can take with you and use at your leisure. Now, I have no idea. I've never seen a wombat. I didn't want any of you to yell out an answer because all of you yell out answers randomly all the time. Right? What's 7 plus 3? 7, 9, 27, minus 4.
16.
Sure, why not? What is one person's equation? See? See what I mean? What is one person's equation? Vicky? Excellent. Now somebody give me another one. 4x plus 1y. Okay. Equals 19. Abso-smurfly correct. Go.
2x plus 3y equals 17.
Yay, everybody can do it. Good. Now, let's turn the page over and see how this new knowledge helps us to solve systems. I will start in red. Add or subtract the equations to get rid of one variable or letter. Get rid of, eliminate. Why do you think it's called solving by elimination? Which of those letters can I get rid of if I add or subtract? Why don't you just go back and sit with them? And then this won't bother me because it'll be right beside each other and it won't piss me off because I won't have to watch it. How's that sound? Jaden, that good with you? Yeah. Okay. So, Mantaj, if you would be so kind as to switch seats with Harry so they can do their crap and I don't have to deal with it. Yes, I'm dead serious. I don't care. If you were talking to Mantosh, then you can switch with Jaden. I don't care. Somebody's got to switch because you're pissing me off. And I want the people that aren't paying attention to sit together so I don't have to watch you not pay attention. Okay? Or you can stay where you are and grow up a little. Which is going to be? Excellent. Elimination means we are going to get rid of one of those letters. Which of those letters can be eliminated? Why is it y? Okay, so that means if it was 2x plus 7y and 3x minus 4y, I could eliminate. No, you need to be more exact, Jewel. Why?
An equal amount of y.
The x, well, no, because one's negative and one's positive. Vicky? They have the same coefficient, but one is positive and one is negative. So are we going to add or subtract? Why is it add? Because they're opposites. And when you add opposites, you get 0. So let us add. And what is my new equation? 7x equals 14. Now what will you do? You will solve for the remaining variable. X equals 2. What does that mean? Where? Does it have to be the first equation, or can it be any equation? It can be any x you see in the question, right? I'm going to do that with green. You all plug it into wherever you want. I'm going to wait a moment to make my decision so you don't just copy me and you actually try it. Oh, it's almost like I've taught classes before. Well, no, because that won't get us y. We already know that one. That's what gave us this. Boom, boom. How many people put x in the first equation? Yay! And you, of course, got 3 times 2 minus 5y equaled negative 9. 6 minus 5y equaled negative 9. Negative 5y equaled negative 15. Y equaled 3. How many of you put x in the second equation? Should be everybody else's hand. It isn't. So, interesting. You, of course, got 4 times 2 plus 5y equals 23. 8 plus 5y equals 23. 5y equals 15. And y equals 3. Did it matter where you substituted the x in? No, it did not. Then your answer is, of course, 2, 3. Okay. Now, is it always this easy? Of course not. Sometimes you'll need to multiply. Remember how we just proved that multiplying doesn't change the results? Excellent. So what are you going to do here? I can't eliminate, Mr. Myers, because nothing's got the same coefficient. Pardon me? Jordy says we could multiply by 2. Is he correct? Yes. What else could we multiply by? 3. If we multiply by 2, what is being eliminated? If we multiply by 3, what is being eliminated? Notice that the one we multiplied was the one with the smaller coefficient, right? Because what would be the point of multiplying the bigger one? Yeah? Yeah. Should we go orange or blue? Antosh? Blue? Sure. I'm actually glad you chose blue for a reason. If we multiplied by 3, what is my new equation? 3x minus 6y equals 21, yes? And now would I be adding or subtracting? I'm going to subtract. Now this is where it gets weird, because a bunch of you say this answer as quickly as you can. What is 4 minus 6? One person said it quickly. One person got it right. Yeah. Why did I just do that to you? No, because when negative numbers come to the party, you sometimes get a little blah about them. So let me offer you this piece of advice. Multiply by a number that will give you the opposite. Here is why. Negative 3x plus 6y equals negative 21. Now you can just add, and you don't have to worry, oh, do I need to flip that sign or not? Do you have to do it? No. Your choice. But I like to get opposites, so I can just add. Yay. So that is going to be 10y equals negative 20. And what will y equal? Negative 2. Where does that piece of information go now? Any y I see. Does it matter which one? No. If I put it in the first one, x minus 2 times negative 2 equals 7. X plus 4 equals 7. X equals 3. If I put it in the other one, 3x plus 4 times negative 2 equals 1. 3x minus 8 equals 1. 3x equals 9. X equals 3. And what is my answer? 3 negative 2. Huh? Now, very scary. What's happening in the third one? I'm really in trouble, aren't I? Or am I? I just need any two of those numbers to be the same, right? So what would I multiply 2 by? 2 is with the x. Where's the other x? 11. So what number am I? 22. So if I multiply that by negative 11 and that by positive 2, will I be in good shape? Yes. What else could I do? What would be the one to work with in y? 6. So this is already negative, so I would multiply it by 2. And this is already positive, so I would multiply it by 3. And then I would have opposites at 6. Which one would you like to do? You guys are awesome. You chose the right one. So, what is this new equation? 4x and
33x plus 6y equals negative 3.
are they opposite?
Yes.
So are we just adding?
Yes.
What's 4 plus 33?
37.
They disappear. What's 4 plus 40 plus negative 3?
37.
What does x equal? 1. What do I get to do with that? Do I have to do both? Do I have to do both shades of green? No. Everyone's cool with that now? Your decision? Yeah? Okay. Huh? Yeah? Easy peasy, yeah? Now, in all honesty, without being punks, which do you prefer, substitution or elimination? They're exactly the same, because at some point you've got to substitute anyway, right? Okay. Basically the same. Now let me ask you this. I'm going to write 2 systems on here. Okay? Everybody cool? Watch. Don't do anything with them. Obviously both methods work with both. What would be most likely a better method to do with the green one? Why? Pardon me? Oh, yeah, I guess you could. I would have said because y is all by itself already. Right? Could I do elimination here? Sure. I could multiply this by 4 and this by 3, or I could multiply this by 7 to get 7. But y is already by itself, yeah? So I could just go y equals 19 minus 4x and start substituting. Over here, it makes more sense to use elimination, right? Because if I multiply this by -2, there's my buddies. Everybody cool? They're exactly the same thing, which is why I do not understand why kids have been so violently opposed to one or the other in the 20 years I've been teaching. It's what they don't understand, Vicky, is both of them are new. And the first time you do something new is scary. And then once you know how to do it, like you already knew about substitution, right? So when we get to the substituting part of elimination, you're all like, oh yeah, no problem. Right? When you go the other way around, when you get to the substitution part of substitution, you're like, oh, I just put it in like we do in elimination. But you never make the connection that it's only because you now know how to do it that the second one seems easier. Which is something I wish I could get across to you people, because the first thing you all say when you walk into every math class is, I stink at math. And then you proceed to not do math. You all say it when you come in here, though. It's everybody's I'm so bad at math. It's my worst subject. And then you don't do it. All right. What do I have for you? I have the usual boring ones to just practice with. But then, yay! Yeah! You should practice elimination. But I don't really care, because I'll never know, will I?